Hello everyone. Today we are going to explain the ML Assignment 1 project Linear Regression and Decision Tree for House Price Prediction. Now I am going to explain the introduction part of our project. Predict house price using a machine learning models. Importance are helps buyer decide if the listed price is reasonable or not, and helps sellers set a competitive price, and assists real estate agents and investors in analyzing the trends. Use cases are real estate pricing tools, city planning, financial investment and strategies in real estate. Next, I am going to explain the dataset description. Dataset source are could be Kaggle, UCI, ML repository, or any public dataset with housing features. Independent variable features are square footage, size of the house, number of the bedrooms or bathrooms, locations, neighborhood or zip code, age of house, years since built of the house, garage availability like gardens, hospitals, etc. Dependent variable are house price what we are predicting. Explanation: the dataset contains both numerical and categorical features. The target is continuous. Next will be explained by Srishti Mandre.
Now I am explaining about the decision tree model concept. Decision tree breaks data into smaller set based on future values using if-else rules. Structure: root node starting point. Internal nodes is a decision based on futures. Leaf node is the final prediction. Advantages: capture non-linear patterns, can handle both numerical and categorical data, less sensitive to outliers. Next, model evolution matrix. In this model evolution matrix used mean absolute error. Absolute error means average absolute difference between actual and predicted prices. Mean squared error means average of square difference. R square means how much variance is explained by the model. Next, we'll explain by Pratna.
Now I'm going tree performed slightly better in this case based on lower error and higher R square. If the data has no linear relationships, tree based models perform better. Importance from decision tree. Tree models gives a score showing how important each feature in making decision. For example, location 40% importance, square 35%, number of bedrooms 15%. This insight helps listeners know which factors influence price the most. Next slide. Conclusion and future work. Conclusion. Linear regression is good for simple linear data sets and interpretability. Decision tree works better with complex patterns and non-linear relationships. Future work methods like random forest or gradient boosting can boost performance. More features: school rating, proximity to metro drive rate, hyperparameter turning, adjust the tree depth, learning rate, etc. for better results. Next, preference. Data source from the Kaggle, Python libraries, pandas, and Seaborn. Articles, blogs, or papers used for research. Thank you. Now we are going to explain about the code. Continued by Kushara Patil.
Of our project. Import pandas as PD. Pandas is used to data manipulation and creating a data frame. Then next train test splits the data set into training and testing parts. Linear regression and decision tree regression are the two machine learning models being used, and mean squared error and R2 score are the evaluation matrix. Next, I am going to explain the creating the data set. This creates a small synthetic data set, each end of our project. Firstly, I am going to explain the importing libraries. Import pandas as PD. Pandas is used for data manipulation and creating data frames. Next, train test splits the data set into training and testing parts. Linear regression and decision tree regression are the two machine models being used. Mean squared error and R2 score are the evaluation matrix. Next, I am going to explain the creating the data set. This creates a small synthetic data set. Each entry represents a year of experience and corresponding salaries. The relationship is perfectly linear. Salary increases by 5 with each year of experience. Next part will be explained by friend Prarthana.
Now I am going to explain the define. Awa, ನೀಕ ಮಿರ್ಕಳವ. Now I am going to explain about the defining features and target. X contains the independent variable experience used to predict. Y contains the dependent variable salary, what we want to predict. Next, splitting the data set splits the data into training 80% and testing 20% sets. Random state is equal to 42 ensures that the split is reproducible. Next, we'll explain by Sustri.
I'm going to explain next part of this code, that is training linear regression. LR model is equal to linear regression. LR model dot fit of X train comma Y train. A linear regression model is created here. Dot fit trains the model using training data. Next is predicting and evaluating linear regression. Y pred LR equal to LR model dot predict of X text. Print linear regression. Next is print mean squared error, comma mean square. Print R2 score, R2 score of Y test, comma Y pred. Dot predict generates predictions using the test set. Mean squared error, it measures the average square difference between predicted and actual values. Lower is better. Usually, R2 score, it shows how well predictions approximate the actual data. 1.0 is the perfect. Next code will be explained by Priyanka.
Now I am explaining the training decision tree regression. In this decision tree regression creates a tree-like model and max depth is equals to 3 limits the depth to prevent overfitting. Dot fit is trains the model. Next, predicting and evaluating decision tree. It makes the prediction using the decision tree model and it calculates the same performance matrix. and the output is it gives linear regression and mean square errors. In this linear regression, mean square error is 0.0, R square score is 1.0. In decision tree regression, mean square error is 40.625 and R2 score is 0.8673. Thank you.